We're going to use molecular mass and molar mass in order to do some further calculations in this section. First, we're going to find percent composition based on a chemical formula. Then we'll find an empirical formula based on experimentally determined masses of some different elements. Our third type of calculation will be finding an empirical formula if we know the percent composition of the elements that make up the compound. And then after doing either number 2 or number 3, we can do number 4, which is finding molecular formula based on an empirical formula. Percent composition, which will be our first type of calculation, is defined as the percent by mass of a particular element within a compound. Essentially, what we're trying to find is how much of a particular compound is made up of a particular element in terms of the masses. The percent composition will be different if the ratios are different. Let's look at two similar compounds, potassium chromate and potassium dichromate. Both of these compounds have 2 potassiums in their chemical formula, but 40.3% of potassium chromate's mass comes from potassium, whereas only 26.5% of potassium dichromate's mass comes from potassium. The reason is that dichromate is a larger ion, and so the 2 potassiums that are with it make up a smaller percentage of the overall mass of the compound. On the other hand, with potassium chromate, the chromium is a smaller ion, and so the 2 potassium ions make up a larger percentage overall of the mass of the compound. The number of potassium atoms did not change, but the percent composition did change because the ratios changed. So how do we calculate percent composition? We take the mass due to one type of element divided by the mass of all the elements in the compound, and then multiply by 100%. Essentially, we're taking the mass of the part divided by the mass of the whole, and then times 100 to change from a decimal to a percentage. Another way to think about it is we're going to take the subscript of a particular element and multiply it by the atomic mass of that element from the periodic table. Then we divide by the formula mass of the compound, that is, the mass of the whole thing. Then we multiply by 100. For potassium chromate, we would need to find its formula mass, or molar mass, to put on the bottom of the calculation. We would have 2 potassiums, 1 chromium, and 4 oxygens. We add up all of those masses and get 194.188. That part goes on the bottom of our calculation as our formula mass, or molar mass, of the compound. Then we just want on top the part that's due to the potassium. The part that's due to the potassium is 2 times the mass of a single potassium atom. Our calculation becomes 2 times 39.098 divided by our 194.188 times 100, which gives us 40.268%. We could do the same type of calculation to find the percent of chromium in potassium chromate or the percent of oxygen in potassium chromate. We'd have something different on the top, but the 194.188 would be the same on the bottom any time that we have potassium chromate. What is the percent composition of hydrogen in C2H2? Is it A, 92.26%, B, 7.743%, C, 50.00%, or D, 17.29%? The correct answer is B, 7.743%. Notice that we're not talking about numbers of atoms. By numbers of atoms, the hydrogen makes up 50% of the chemical formula. But by mass, which is what we're typically talking about with percent composition, hydrogen makes up only 7.743%. That's because hydrogen is lighter than carbon, so it is going to contribute less to the mass of the molecule.